Geometry Unit 4, Lesson 7. I can use the Pythagorean theorem and triples to solve real-world problems. So triples mean groups of 3, and Pythagorean theorem is like a squared plus b squared equals c squared. So we're going to go ahead and work with these triples today. There are others, but it turns out, as we focus on them, that these relationships, a 3, 4, 5, and a 5, 12, 13, always work in the Pythagorean theorem. Let's take a look. If we take a look at the first one, 3, 4, 5, let's show that using the Pythagorean theorem, it's going to work for these sides. So opposite my 90 is going to be my c. So I'm going to go ahead and write in a squared plus b squared equals c squared. I'm going to put 5 right in for the c, the longest side. And then 3 and 4, it doesn't matter where they go because it's commutative. So we get 9 plus 16 equals 25. And finally 25 equals 25. So it turns out when you have sides of 3, 4, and 5, you do have a right triangle because 3 squared plus 4 squared does equal 5 squared. Now, here's the thing. Up here it says something called a scale factor. Scale factor is the number that all sides are multiplied by. So if I come back here, take a look at the next triangle down in number 2. It looks like a 3, 4, 5 if you look real closely. Here's your 3, here's your 4, here's your 5, except there's been a scale factor. And if you don't believe me, just go ahead and sketch out really quickly the right triangle that you have. And then notice this. This would be the 3, 4, and 5. Except to get from 3 to 30, what would you have to do? Times 10. From 4 to 40, times 10, that works too. And from 5 to 50 is also times 10. As long as all 3 have that relationship, you're good to go. The scale factor is 10. So this is a 3, 4, 5. And a lot of times what we'll do is we'll rewrite this here as 3 times 10, 4 times 10, and 5 times 10 to prove it. And there's your scale factor right here, 10, 10, 10. 3, 4, 5, scale factor 10. So the game today is if you can get 3 sides and realize, showing it this way, that it is really a 3, 4, 5, you know immediately that it's a right triangle. And watch how that helps us find a missing side. Make a guess at what x is. Confirm your guessing using the Pythagorean theorem. So take a look at this. You might go, okay, x squared plus 8 squared equals 10 squared. A squared plus b squared equals c squared. And that would be fine. But watch how I can do this even quicker. I see this 10, and that makes me think of 5. So look how I'm going to sketch this over here for just a moment. I think it's a 3, 4, 5. If this was 5, I think this would be 4, and this would be 3. How am I making these decisions? Well, I'm trying to think of factors of 10. And what times what is 10? Well, 2 times 5. Well then, if this was a 5, this should be a 4, and it better be 2, and it is 2 times 4. So if this is 2 times 4, and this is 2 times 5, this would have to be 2 times 3, because it's supposed to be a 3, but you can see it was doubled, so this will have to be doubled as well. And what is 2 times 3? 6. Again, you can see the scale factor in this case happens to be 2, while we still have a 3, 4, 5 hidden inside. So you need to factor each of these to hunt for what the scale factor might be and to make sure it's a 3, 4, 5. Now this is one type of triple, the 3, 4, 5 combination. There's one other very common one, and it's called a 5, 12, 13. Same concept. Let's go ahead and check it. Across from my 90 is my c. So I have a squared plus b squared equals c squared. Let's go ahead and put 13 in there. And then I can put 5 and 12 wherever because it's commutative. We get 25 plus 144 equals 169. And indeed, 169 is equal to 169. So when you have a combo of 5, 12 for the legs and 13 for the hypotenuse, you have a right triangle. So let's go down here and see what we can see. Is this a 5, 12, 13? If you take a close look, yes it is. I mean, 13 would have to go here. And this is 13 right here. Except what's the scale factor? Times 2. Now it would have to be the same over here. I think this would be a 5 and I think this would be a 12. Because that was double. This would have to be double too. 2 times 12. 2 times 5. And it did work for all three. The scale factor happens to be 2. And there it is, hidden inside a 5, 12, 13, but it's been doubled. Let's use this idea to find a missing side again. Make a guess at what x is. Now it looks complicated, but stop and think about it for a second. What are factors of 25? Well, 5 and 5. So maybe this would be the 5, and does 12 go into 60? And you know this would have to be 13. Let's just test it out. 5 times what would get you 25? Oh, that's 5 times 5. 12 times what gets you 60? Well, that's 5 times 12. Well, this better be 13, except what times 13? 5. 5 times 13. And indeed, all of these do work. So what's the answer for x? X is equal to 5 times 13, or in this case, that's 50, it's 65. The scale factor here was 5. Now, we've dealt with a 3, 4, 5, and we've dealt with a 5, 12, 13. There are others, but these are the two we'll use the most. And then when I come down here, I'm going to mix and match, and I'm not going to tell you which one to use. So if you want, you can hit pause and try these on your own. What do we have here? Is this a 5, 12, 13, or is it a 3, 4, 5? Okay, here I go. So I'm going to look at this, and I'm going to look at the legs. I see 15. Factors of 15, 3 and 5. So maybe it's going to be a 5, 12, 13. The factors of 36, there's a bunch. But I'm going to experiment. I'm going to say this is a 5, and this is a 12. So what times what is 5? Well, 3 times 5. Sorry, is 15. Now I better hope it's 3 here as well. Yes, 3 times 12 is 36, so I think we have it. It's a 5, 12, 13, except this one has to have the exact same scale factor, don't forget. So I'm going to go ahead and make this a 3 as well. Therefore, x is going to be equal to 39. You have to be brave enough to experiment with the factors. Go ahead and try the next one on your own. Okay, here I go. So I'm looking at the hypotenuse here, and it's either going to be a 3, 4, 5 or a 5, 12, 13. Does 13 go into 20? No. So it's probably not a 5, 12, 13. But 5 does. What times 5? 4. Okay, what about down here? 4 times 4. So if this was going to be a 3, 4, 5, 4 is the scale factor. So that means I would go ahead and do 4 times 3 to get 12 for x. So x in this case equals 12. You can try one more by yourself. We have 20x and 52. You can hit pause and try it. All right, here I go. I'm going to hunt around here. I'm going to look at the hypotenuse again. I think it's the easiest to remember. It's either going to be a 3, 4, 5 or a 5, 12, 13. Does 5 go into 52? No. So it's probably not a 3, 4, 5. So we're going to guess it's a 13. What times 13? I might go off to the side and experiment, but it turns out it's 4 times 13. So the question is, what's this, the 5 or the 12? Well, 12 doesn't go into 20, so I'm going to guess it's a 5. And in this case, it's also 4 times 5, which would make this the 12, and it'd have to be 4 as well. So here's my 5, 12, 13, with my scale factor of 4. And if it helps you to sketch off to the side and see, oh, times 4, times 4, times 4, then definitely do that. So therefore, what's x going to be? X is going to be equal to 48. So be brave and factor and use what you know to determine if it's a 5, 12, 13 or a 3, 4, 5. Find that scale factor, and it's going to help you find what's missing. Good luck.